Hi. Yeah, it's very nice to be here tonight. I already saw some really interesting things and also some familiar faces from the React community in the Netherlands, so that's really good to see. So let me get started. So it's ReasonML for React. So what is this about? Of course, it's about React, it's about Reason, and I will show you how you can benefit from all the extra functionalities from Reason inside a React.js project. So React Reason uses OCaml, which is not really different from the JavaScript syntax, but it's a small difference, and we're going to deep dive into to see how that works for you. So this is actually a meme from I believe Zoolander saying that ReasonML is so hot right now. For every JavaScript developer, the possibilities are endless, and there are new features, frameworks, or other interesting stuff, packages coming to the community every day. So ReasonML is not really one of those packages, but it's really an extension built with a different syntax, but allows you to really explore all the interesting stuff that JavaScript has. And for those people that are thinking it might be in hype, or maybe another framework that is being overhyped by the community, it is not. It is actually built by Facebook. Along the same time they built React, and actually React was meant to be built in something other than JavaScript. So that's when they came up with Reason, and he kept it sort of under the hood. But now you have Messenger.com, like Facebook Messenger, and it's almost for 50% built on Reason. So I believe it's a real game changer, and also Bloomberg adopted it into their ecosystem. So let's look at it. So let me tell you a little bit about myself. So I'm Roy. Next to a developer, I'm also an entrepreneur, a startup CTO, and I tweet a lot about JavaScript and everything related, like the newest frameworks or packages. I started programming when I was like 16-year-old, and I wanted some extra money, and my parents didn't want to raise my pocket money, so I got into development. I checked how I could make a website, how I could sell a website to other people, and eventually created my first marketplace that was used to buy and trade used DVDs with other people. I really started learning out by myself, and then I went to university, I learned even more, and then JavaScript came my way, and I started all the way from jQuery to React, React Native, and even ReasonML right now. So what's this presentation for? Who here uses TypeScript and Flow? Okay. I'm not really sure, but do the people that use Flow already know that it's also built on top of OCaml, the same as Reason? Okay, that's good to hear that some people at least know. Yeah, so TypeScript and Flow, they both do some stuff that Reason also does, but a little bit different. So let me first explain what Reason is. So Reason is built on OCaml, and OCaml has been around since somewhere in the 1990s, and it's been it's an ML language, which means it's really functional. So JavaScript isn't perfect, and some people believe Reason is, or at least OCaml is, so people started to develop ReasonML on top of OCaml, which you can compile to JavaScript using BuckleScript, which is made by almost the same people as that made Reason, and you could use it to compile to JavaScript. Natively, Reason can also compile to stuff like assembly, or maybe other languages if you use the right packages, like BuckleScript is for JavaScript. So who's this really for? It's mostly for the people that are sort of irritated by the stuff that JavaScript likes due to its dynamic type system. And that's basically one of the reasons for me to say why not just use JavaScript. JavaScript is fine, but it lacks some stuff. I use JavaScript for almost everything, ranging from web applications to mobile applications to APIs or microservices or even machine learning software. But the biggest downside remains its dynamic type system. What will types do? Maybe some people don't really know what types are. With types you can really define the structure of all the data that flows into your application. So it will improve stuff like code readability, detection of code errors. It also will give you some analysis about your code. There's really cool IDE support, so the people using here that are using Visual Studio probably know about all the extensions for TypeScript or Flow to really make their development experience really strong. And also refactoring becomes way much easier if you've got all these types and you know what data is flowing into your application. So why not TypeScript or Flow? As a lot of people are using TypeScript or Flow or maybe both. In my opinion, they offer like a partial solution to the problem of the dynamic type system with JavaScript. TypeScript is probably the most popular if you compare it to Flow. More people are using it than people are using Flow. But still you need stuff like immutable JS or runtime packages to really get everything like pattern matching and that kind of stuff. So for me, TypeScript is still not really soundproof. And I believe reason is. It's almost impossible to inject, or I believe it's impossible to inject data that's malicious into your JS code base. And that doesn't apply to the type system that you've set before. And with Flow, Flow is also built on top of OCaml, and it runs on top of JavaScript, so why not just use Reason in the start? So let's get started by creating a Reason React project. We'll use a package called Reason React, and we will also use the BuckleScript platform to transform our Reason code into JavaScript. And along this presentation, I will use JSX, which probably most of the people that are using React are using. You can also use it without JSX, just as you can use JavaScript and React without JSX. But for now, I just stick with JSX to make it more readable and clear for everybody what's going on. So BuckleScript can be installed just by running an npm command, and after that you can use the bsb command to initiate your first React app. And something that's really important right here is that you also add a team called React to your application, so you can really get the React development experience. After that, we just install the new project and we run it. And then something what might feel a little bit odd is that Webpack isn't integrated in the process. So you have to run Webpack in a different terminal or command prompt. And as you can see, we got a really nice structure with inside of our new application. And the really important stuff goes on in the RSC in the source folder with the index.html, where just as with React, our source code is built, and the index.re, what is our reason code, and the index.bs.js that is compiled by BuckleScript. You won't need to change something that's inside the index.bs.js because BuckleScript does all the hard compiling for you. So first start by seeing what a Reason stateless component look like. Like this is the stateless component you probably remember from all the React applications you've built. So we just import React, we create a small stateless component, and we render it using the React DOM. In Reason, this looks a little bit different. As you can see, we still have the React DOM, or somehow a different version of the React DOM, where we inject some JSX with a prop called React Amsterdam in this case. And we define our component, and then all the magic happens inside the make function, where we define our prop. So in this particular situation, it is only name, which we will render. And then we have a Reason React string that outputs hello name. So below you can see the output that this function will generate. And then, so here we have our JSX, and we have the props and the output of the props. And this sort of compiles to the React create element binding that is in Reason React. So so if we would define the strong type system for Reason, we can mostly easily do this just by changing our prop. So our prop used to be a string called name React Amsterdam, and now we change the name is 9. What would happen? As you can see, inside your terminal you would get an error message saying like this. We would expect a string, but we got a type. And it's, we got a string, but we expected an int. We got an int, but we expected a string, sorry. A bit messed up here. Okay, so as you can see, we get this error in your console, and you know immediately that you're doing something wrong. And that is really from Reason's strongly typed system. In JavaScript, you would get something like undefined variable x, blah, 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 or you can't read null. And for this, it's a real game changer. So now if we would send some other prop to it, so we used to send just the name property, and now we're also sending visitor, which is an array containing just the strings called visitor. Inside of our application, we have set the type for visitor that is fairly different. So let's see what it would make up. And then again, we would get an error saying like, hey, this is not what we expected. We expected our list, as we composed here. This is something other that the reason React is doing. You can create a list in a map function from just an array of objects, and they automatically map it for you. So we get an error because we gave the wrong information to our function. So suppose we give the good information to our function, it would look something like this. And yes, as you can see, our ID is an integer and not a string, so we have to transform it from an integer to a string, so we can use it with the reason React string binding. And then the output will look something like this. So we have some divs containing the number of visitors we put in initial props, and then saying hello React Amsterdam. And next to stateless components, you also have stateful components. And stateful components, they can access the life cycles or even mutate states, that kind of stuff. So in React, it will look something like this. You have your constructor defining your initial state, and then you have multiple life cycle changes over that. So like the component did mount, you can also put in other ones. And then ultimately you render your function, and the React DOM will take care of the last bit of that. So suppose we're going to make a stateful component in Reason. It looks a little bit different, and it's also not called as the other component was called the stateless component. This one is called a reducer component. And with the reducer component, we can access all the life cycles that are available in React, but just with all the type handling we saw before. And wait a minute, we're going to try to make a reducer component without defining all the route type info. So we need to define the make function, define the reducer, and also give it a new state. So as you can see before, we just used our regular stateless component and tried to make a reducer component out of it. Something that happens a lot in React is that people use stateful components for stuff that could also be stateless. So Reason helps you by notifying you that you're doing something wrong, and that you could also make a stateless component. And if you want to make a stateful component, you need to add the right properties to it. So now we added the state, and in this state we expect visitors to be a list of visitor, and visitor will have all the information of that visitor inside. So we used the name and ID before, so we're going to make that a string and an integer. But if we don't do that, we also get an error like, hey, where is visitor? So we're gonna put the type visitor, which we access in our state. We're gonna put it a little bit up, and then our code will look something like this. I hope you can all read it. But let's start at the beginning. So this is the entire code for a stateful component. So we're gonna start by defining the state. So this is where you give the format for the data of everything that's inside your state. So you define if something is an integer or a string or maybe an array or a list of objects. After which we're going to define the actions. So it's a bit comparable to Redux. You define the actions here that you can access later on. After defining the state and the actions, you're going to declare the initial state inside our make function. And the make function is it's like the class in React. Here we're going to define our initial state. We're going to give up like count is equal to the length of the visitor list we have, and visitors just equal to the visitor stuff. And after that comes the most important part, and that is the reducer. So in a reducer, we have a switch statement where we can access our actions, and our actions can update the state. And for here, it looks quite easy. We're just going to update the count a bit, so we would have more visitors. But if we're going to zoom in on this part, as you can see, you have here something that's called self. Self is the equivalent of this in React. So you don't have to deal with all the this dot blah 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 anymore. Everything transforms to self. And as you can see, we use the self.send here to access the action. And our action will mutate the state we've declared before. And next to just updating the state, like you can compare it to set state, we have different kinds of bindings from Reason React to update the state. So we just have the regular update state with which mutates entire states. We also have side effects. So next to just updating the state, you can also update different states or execute another function. You also have side effects that don't exect self. So you see self and underscore self. Underscore self is where self is neglectable. I forgot something. Yes, and in the end we have update with side effects, so you can update both the states and both send the state we can access through self to a different side effect, so a different function or maybe a different component that you also would want to update or do something else with. And if you go to this is another thing that comes from the strongly typed system Reason has. As you can see here, we can just use the spread function to spread the state inside our mutated states. I've added something along the end to increment our number of visitors and also to add a new visitor object to our array. As you can see, we would get an error inside our command center and our terminal that states all the fields are already explicitly listed in this record, so you can move the spread. So as you can see, we just have two parameters in our state, and those are count and visitors. So we don't need to use the state spread anymore. And this is something that's really cool that Reason does. They update you with this kind of information. So we can just remove the spread state and we will be fine. And it will look something like this. And our output will look something like this. So this is generated by the Reason React DOM. And this probably looks maybe a bit overwhelming and maybe not everybody could tag along. But we can also use this inside a React application. And all the Reason React bindings gets compiled and you can actually use them inside our Create React application, which is something I will show you in a bit. So I assume we have installed a Create React version 2 application, and we're going to use the component we just created with Reason inside of this Create React application. So first, we need to add the BS platform and Reason React to our Create React application. After which we will place a BS config.json inside of our root project, and this is where all the compiling settings are listed. So as you can see, you have the Create React JSX setting for Reason in above. Below you have the BS buckle script dependencies for Reason React. And also we have set a specific folder where we're going to place all our Reason files that need to be compiled to bs.js files. So the next step would be to edit package.json to use buckle script. So for this is the command to run buckle script is bsb make world command, and this will start the compiling process from Reason folders to all the stuff you need in bs.js. So if we would have, so assume we have our component from Reason again, so the let component, the let make, then we need to add something below to define that we want to transpile this to JavaScript. So in here you can see that just below the make function, we're gonna let buckle script know that we need to define some JS props, and those are props that we can inherit from the JavaScript application into this Reason component. So now we're going to say we're going to accept name as a string, and we're also going to accept visitors as a list of the object visitor. After which we're going to make a default, default export. You could also export multiple ones and then import them differently, but for now I just keep it by one default. So you see the Reason React binding for web Reason for JS. We're going to put in our component. We're also going to send our JS props in there, and we have another make function that makes the component we want to use in our JavaScript application. So we're going to send name and the JS props. You can see the error with the name get. It's actually something that comes from the bs.deriving abstract, And this makes sure that we won't get any malicious data from the JavaScript application into our Reason component. So as you can see, that's the first part where we really define the type for our JS props, and then we're going to export them here. So how would this look like inside of your React application? You might remember the JSX declaration we did before. So we have our component, it's called intro for now. And we can just import it from our Reason Components folder with the right file name. And then we can just put in some JSX to also send the props in there, for we have the name React Amsterdam and also visitors, which is now empty. But you could also send in some other states you derived, or maybe you have Redux running in your React application. You can also send those values right to your Reason component. And for this, I will try to show you the real life code. I'm not sure if this will. Yes, it works for the first time. Okay, so I hope you can all see this. So here we have our React application, which is created with create React app. We have our React scripts running, and for the build process, we're gonna start with make world, and then after which we start the React server. So as you can see, the only things I added in here is this part where I add the command for BuckleScript and the dev dependencies, which are the BuckleScript platform and Reason React. After which, if you might recall, we also need to add in a bs config file where we have resources, so our Reason Components folder, which is right here. And we're going to say that the output should be bucklescript.js. And we're going to use Reason React for it as we have a React application. Okay, so if we go inside the source Reason Components folder, we can see our Reason file right here. Let's start at the top. So we have declared our types, we've declared our state, we've declared the actions to add and remove visitors to this list, after which we declare a component, and it's a reducer component, so it means we can access all the life cycles. After which we're going to start the make function, set the initial state, which is here derived from the JavaScript threads. So everything we send here, so the name and visitors, can be accessed right in here with name and visitors. And children is something that's Reason asks for it. I can go into details, but it's probably not important. With the underscore, or you can just use underscore, whatever you want, to let Reason know that these are the children. And in a reducer, we're going to access this the state. We're going to change it. So we have add and remove. We also have our list here again. And as you can see, we have this button that adds a visitor. And we're on this one that only detects count right now. It would be like a little bit overkill to make something that also deletes the last object format. But as you can see, it works just inside our React application while it's not React. So this bottom part makes sure that we can execute it in here. It's a typo, I'm not sure why it's in there. So as you can see, we've just created a regular React application with Reason inside of it. So, yes. So what else does Reason has to offer? So we just saw we can use it inside a React application. It also compiles naturally and natively to something like assembly. And you can also, with a strong type system, you won't get any null errors or undefined errors. And it's almost impossible for malicious data to go inside your application. And it's also very specific. It also allows for runtime pattern matching of variant types. But it's most fitting to transfer to JavaScript. So if everything else fails, you can also just insert raw JavaScript into Reason, and it will compile very well. So if you might think, why do we need a different syntax to achieve this? We have TypeScript or Flow, like I mentioned before. This is like an addition to that. You don't have to use it if you want to access its most supported features. Like some of them are already in TypeScript or Flow. But if you want to do something new and maybe want to insert some more functional programming into your daily life, then you could use ReasonML. And in terms of security, it's the best you can get, as its type system is 100% rock solid. And yeah, it will save you a lot of time on checks and unit tests and all that stuff to get to know more. So if you want to actually get to know more, then you can go to Twitter and find me there, or you can go to the ReasonML website. And the code I just sent to you, you can also find that code on GitHub. So you can clone this repository and use this actual application at your own home, and maybe make your own Reason component, which you can also insert in React Native, by the way. So yeah, just let me know if you have any questions, or else that will be it.